Everybody, thanks for coming. And thanks to the organizers of Developer Week for putting on this conference. So my name is Christine. I'm a software engineer at ZenHub.
Woo!
Here's one slide about ZenHub. ZenHub's a project management tool. It's like Jira or Trello, but I think it's better, maybe because I work there. Okay, so I found the most interesting guy in my office while I was preparing for this, and I was like, I have to talk for 50 minutes. How do I make it interesting? And he's like, you need a story. You need a story in and out of everything you're talking about, and like come up with the ending. And I was like, I don't know how to do that with functional programming, but I'll try my best. So every good story has a villain, and our villain today is code that's unreadable, complex, hard to reason about, and hard to test. And why is this the villain? Because this leads to code that has bugs. So those two code screenshots over there is code from the ZenHub code base that was written like 3 years ago, and nobody will ever touch it because they don't know quite what will happen if you go there. Probably bugs. And I would venture to guess that most of you have code like this in your code base somewhere. So this villain is represented by what Apple calls a smiling face with horns, because it might be okay. You're like, oh, it'll be fine, I'll just write this one function, smiling face, and then you go and touch it like 6 weeks later, and then the horns show up and you don't know what's going to happen. And then we have a hero. The hero is functional programming with Ramda. And the hero is going to be represented by what Apple calls the woman technologist, because, I don't know, maybe they're heroes. So JavaScript actually gives us the tools that we need to write clean code, but people often just don't leverage them. So today I want to introduce you to aspects of functional programming, and I want to introduce a library that can help you to write functional code in JavaScript, because I think that this results in cleaner code. And your software can benefit from cleaner code because it's easier to test, it's easier to debug, and it's easier to maintain in the long run. So by the end of today, we're going to take a list of tweets and we're going to analyze them using the aspects of functional programming that I'm going to talk about. So we want to know what are people tweeting about? Donald Trump, Developer Week, NFL playoffs. And we're going to take this, we're going to end up with this function that I think is clean, and with the help of our woman technologist, we're going to end up with this graph with different numbers, but that graph. So, firstly, before I get started, I just want to introduce you to functional programming. I'm not sure, it's kind of a trendy thing right now. Like ES6 came out and they have a lot of aspects of it that help you to write code in a more functional style. React and Redux, which are the major JavaScript frameworks, these are based in a lot of like functional program. They have a lot of inspiration from functional programming concepts. So functional programming is a programming paradigm, similar to like object-oriented programming or imperative programming, and some languages only allow you to write in one paradigm. So like Haskell, for example, you just write functional code. C#, Java, these ones are object-oriented programming language. JavaScript is kind of a free-for-all, you can do whatever you want with it. So while like object-oriented programming, this focuses on objects and like manipulating and performing actions on them, functional programming is all about the functions. So you're going to break your code down to simple functions and combine them together to write your program. The part of functional programming that I want to talk about today is functional programming as a coding style or a mindset. So you can begin thinking in a functional mindset and start adding these aspects into your code base. You don't need to rewrite your entire code base in a functional language or anything like that. It's actually impossible to write an app in a purely functional style that is useful, which I'm going to get to later, but you can just take the best aspects of this and quite easily start writing code in this style today. So the other thing I'm talking about today, this is Ramda, and Ramda is a utility library similar to Lodash or Underscore. And so you can use the well-tested building blocks from these libraries to perform common actions that you would perform on lists or objects. But Ramda focuses on a functional approach. So Ramda's philosophy was to make aspects of functional programming simple in JavaScript. And they saw two major flaws in underscore and Lodash that didn't allow this to happen, so that's why Ramda was created. So today, just a brief overview of what we're going to talk about. We're going to talk about some of the important aspects of functional programming. Then we're going to talk about why these two flaws that the creators of Ramda saw in Lodash underscore. And then we're going to talk about function composition, and then we're going to look at some tweaks. So a year and a half ago, ZenHub was using like some combination of Lodash underscore and Ramda. Basically, like whatever you wanted when you went to work on a file, you could use that. We have a lot of data processing in our application, and so this is where aspects of functional programming that I'm going to talk about, this is where they kind of shine, is when you have this data processing to do in your application. So for our team, there was a small learning curve, but the end result was a much cleaner code base, and so it worked for our application. When we were learning it, I had a lot of fun learning. I didn't know much about functional programming. I had a lot of fun learning it, which is basically why I'm here today, because I actually thought I had a great time. It was really fun. So if you don't want to start using it in your code base, it's worth looking into. I think it makes you a better programmer if you learn about these types of things. So the first kind of aspect of functional programming is immutability. So this means objects cannot be modified after they're created. And because Ramda is focused on functional approach, it's guaranteed that none of their functions will ever mutate the data that you pass it. And why do we actually care about this is because when you modify objects outside of the function where they've been created, you can end up with unintended consequences, and these are difficult to detect sometimes. So I'll just show a quick demo to demonstrate immutability. So we have a tweet here. Welcome to Developer Week. And the dot operator in JavaScript. Can you guys see this?
Yeah.
Okay. So the dot operator, this is going to mutate this object. So like, if I made this tweet, now when I look at tweet, it's being changed. Ramda has r.assoc, and that basically adds in, if I want to do this again, and I'm going to change this user to like Bob. Pass it a tweet. So Ramda's assoc, it's never going to mutate any of your input data. So it's going to return to you a new object with the updated user, but the old object has stayed the same. So that's immutability. Oh yeah, this is the code that I just was working on. So yes, here's our villain. It's like sneakily changing properties in the background. You don't know. You might not know. So when we go to debug this later, we might end up with some unintended consequences. And our hero, Ramda, changes the favorites property, and our tweet stays the same. Another aspect of functional programming is referential transparency. So this means two things. A function is referentially transparent if it's pure and if it's side effect free. And random functions are all referentially transparent. So a pure function means that given the same input, you're always going to get the same output. So your function doesn't depend on like any hidden information or any state that changes as your program executes. And oh yeah, we have an example of this. Okay, we have a list, and we have JavaScript's built-in reverse function here. So we're going to call it once. We're going to get 5, 4, 3, 2, 1. We're going to call it again, and we're going to get a different result. So this is not pure. And side, hero. No, sorry, that's not hero. That's the villain. This is our hero. Okay, now side effect free means that you're not going to modify any state outside of the scope of the function. So the first example, the top example, our counter, which is like a global variable, is going to get changed. And the bottom example, which has no side effects, we're not changing any global variables. So whenever you call increment side effects, no matter what, you're going to change this global variable. And the important part about referential transparency is that, like, given any context, the expression, your function expression, is always going to evaluate to the same result. So you can actually replace a function call with like the value that evaluates to, and the execution won't change. So this means that the functions are really easy to test, because when you're writing tests, you don't have to worry about like setting up a state and then resetting the state after every time your test executes. Every single time you call a function, you're going to get back the exact same result. It's controlled, and yeah, you know exactly what you're going to get. That being said, there are functions where it's necessary to have side effects or to have functions that are not pure. So date.now and like math.random, these are obviously not pure, not referentially transparent. You call math.random, you're going to get a different result every time. And that doesn't mean you shouldn't use this. It doesn't mean the function's bad. It just means that it's not pure. So you want to take these functions that are not pure, and you want to kind of contain them and like apply these things in a controlled way. So another example of something that we use all the time that has like side effects that's not referentially transparent is like writing to the console or making an HTTP request. So these things have side effects. And as long as these are contained and you're aware of them and they're not just thrown like anywhere in your application, then you're going to be aware that when you're calling this function, this is going to have a side effect and it's going to be controlled. So the like unintended consequences that you get from mutating the state and stuff in your function, you won't get those because those will all be contained. So as I said at the beginning, it's kind of impossible to have a useful application that's purely functional, and that's because of this idea. You need these side effects in order to like I don't know what kind of function you can write that doesn't render anything to the screen or have these side effects. Another aspect of, oh yes, so this is our hero and our villain, other way around. Our villain has the side effects and our hero, no side effects. Another aspect of functional programming is first-class functions. So that means that all functions are just objects. You can assign functions to variables, you can pass in a function as an argument, and you can return a function for a function. So this is built into JavaScript. In JavaScript, functions are just regular objects. We can see some examples here. So we can just assign math.abs that function to a variable, we can call it, we can pass it into this function. The reason why this matters is for currying. So to explain currying, I'm going to use this example here. So we have a regular implementation of an add function. If you call add with just one parameter, you're going to get back not a number, because 1 plus undefined is not a number. If you call add with both 1 and 2, both parameters, you're going to get back the value with the result. So when you have a curried function, if you call curried add with a subset of parameters, just 1, you're going to get back a function that remembers the 1, and then when you pass another, here you're going to get back a function that remembers the 1 and is waiting for the final value, and then when you pass that value in, you get back the result. So like at the bottom here, we have add 5. So we call curried add with 5, so the result is going to be a function that remembers the 5, and then you can just call add 5 with the remaining parameter, and then you're going to add 5 to that number. It's a bit hard in this example to see why this is useful, but when we get to the function composition, then we can really see the benefits of currying. So this isn't actually like the villain. It's not bad to write a non-curried function. I just have to put the villain there for some comparison. And our hero is currying. Currying is cool. So yes, here's my definition. A curry function can be called with a subset of its parameters, and it will return a function that expects the remaining parameters. So like our top diagram is just a regular function, so you pass all the parameters at once and you get back a result. Or if you pass a subset of parameters, you're still going to get back a result. It's probably just not what you're expecting. And then in the bottom there we have a curry function, so you can pass it one parameter at a time, and you're going to end up with functions that are waiting for the remaining parameters. So why do we want to use Lambda? Basically, built into Ramda's philosophy is this ability to easily compose functions. And so, as I said earlier, they saw two flaws in Lodash and underscore that didn't allow for functions to be easily composed. So here we are in our top, halfway there. So the top half just reviewed some of the aspects of functional programming, and now we're going to talk about these two features of Ramda and why those matter. So Ramda has automatic currying, and Lodash and underscore don't. There is Lodash functional, like the Lodash released like a functional programming library, and that does have these two aspects, but Ramda was built before this library. So there's automatic currying. So that means that by default, all Ramda functions are automatically curried. So you can take a Ramda function. R.prop is a function that just gets the that property of the object you pass it. So if you have a tweet, R.prop is going to return to you the value of the user prop. So if you call it with the name of the prop and the object, you're going to get back the value. And it's automatically curried, which means that if you call it with a subset of the parameters, then it's going to give you back a function that remembers that and is waiting for the final parameter. So we can make a function that's called getUser, and R.prop is going to remember user, and then it's just going to be waiting for the object. So you pass it tweet1 and you get back the value. You can pass it any tweet and you'll get back the value. This is our hero here. She likes this type of thing. Okay, so function first, API. Ramda has an API that's the reverse of JavaScript and Lodash and underscore. So it expects the function first and it takes the data as the last parameter. So this is Lodash's filter function. So that takes in tweets as its first parameter, and then isPopular, which is the function to filter by, as the second parameter. And so if you want to write a reusable function that is going to filter popular tweets, then you would have to define the tweets parameter and pass that in first. Often, we wouldn't really do that with Lodash. You would just call the filter function twice, and there's nothing wrong with that. But it's really cool when you see it with Ramda, because Ramda has automatic currying, and then the data is expected as the last parameter. So you pass it the function, isPopular, and you don't actually need to define the parameter tweets in order to call that. So this is automatically curried, so you call R.filter with isPopular, and then you just pass it whatever tweet list that you want. So we can reuse this function quite easily, and it's really clean. Like, you don't have to declare the parameter called tweets. This type of function is called a point-free function, where you don't declare where you don't specify the data as the parameter. Okay. So why is this important? So remember, as I was saying, Ramda's philosophy is the ability to easily compose functions. And the combination of currying and a function first API allows us to compose functions really easily and with very little code. So what actually is function composition? Function composition lies at the heart of functional programming. In functional programming, you can split your program up into like small pieces that you can combine and reuse in different places to build up your application. So function composition is the process of passing the result of one function to the input of the next function. It comes from math. Like in math, you compose functions together, like f of g of x. This is the basis of function composition. So what you can do is you can chain together multiple functions to make a sophisticated system out of simple parts. So you just combine simple building blocks up into a more sophisticated, complex function. Reading about function composition, kind of the image that sticks out in my mind is you're creating a pipeline, a function pipeline to process data. So you're going to compose together functions into a pipeline, and then when you have the final function that you want, you drop your data in, and then that gets processed through your function pipeline. So function composition is really like the main part, like the core kind of aspect of functional programming that I think is really important for writing clean code and can easily be added into your code base. I found this quote and I kind of like it. The problem is that you can't avoid composition just because you're not aware of it. You still do it, but you do it badly. So most of you have done, like this is quite a common thing to do in writing software. You have data, you want to do stuff to your data. So you are doing function composition, but you could probably be doing function composition better. So this is our smiley face with horns. Okay, so just to kind of give you an example of what this is like, let's say that we want to format a string so you encode it into your URL. So if we think about what we want to do here, we can break it down to a series of steps. So first, I want to take my name, I'm going to split it. I'm going to split it at the spaces, and then for each of those strings, I'm going to map them to lowercase, join them together with dashes, and then encode it. So this is just one way that you might want to encode a name into a URI component. There's different ways to do this. This is by no means the only sequence of steps. This is what we're going to work with today. So one way you can do this is in JavaScript, intermediate variables. So I've written code like this. Most likely you guys have written code like this. So you have intermediate variables. So you take your input, which would be Christine Legg, and then this first step is you're going to split it, assign that to a variable. Then on that variable, you're going to map to lowercase, and then on that variable, you're going to join it. And then you're going to encode the URI component. So there's nothing wrong with this. There's nothing wrong with this code, but it could be better. It could be more readable and more reusable, and you can make like the function pipeline that you're sending the data through more clear. So this is our smiley face horns. So there's nothing wrong with it, but the horns might come out later when you want to reuse or make minor tweaks to this function. So here is, I don't want to say the proper way because I don't have the authority to say what is the proper way to write code. But here's how I would do this, based on the principles that I've been talking about earlier. So so Ramda has a pipe function, and pipe is one of two Ramda functions that allows us to compose functions together. So it basically is like the glue that's going to like stick our pipeline together so that it will process the data that we pass through to it. So how it works is that the data we pass through is going to go to the first function, and then that first function is going to return us, well, it's not going to return us. Okay, we're going to pass data in, and then the result of calling the first function on the data is going to be passed into the next line, and the result of that is going to be passed to the next line, and the result is going to be passed to the final line, and then we get back one final result. So if you look at this with the type signatures, you can see that the result of each line is the input into the next line. So on a diagonal, these type signatures should match up, otherwise this isn't going to work. Now here we can see that the sequence of steps that are defined in the pipe function map directly to the sequence of steps that we decided that we wanted to do at the beginning. And say like I want to reuse any of these components, or maybe I want to add in another step, or maybe I want to like change one of the steps I want to join by something else, you can easily just add in more steps or take these out and reuse them elsewhere, and it's really clean and easy to reuse in that way. So here we can also see where the currying and the function first data last API has allowed us to compose this code has allowed us to easily compose this code. So r.split, this is the same as the split in native JavaScript, and it's going to this is automatically curried, so it's waiting for our data, which is this string. And because that's the last parameter, we can just add that line in there. If we were going to if we're going to do this with JavaScript, it's also possible to follow these sequence of steps, but it's not quite as clean. And Lambda gives us the ability to do this very easily. So this is our hero here. So this is how we might write something in a similar way using native JavaScript. And using native JavaScript or using low-v, rather than composing functions where we can use .chain, and then you just chain functions together. Your code ends up looking quite similar, and it also has this benefit where you can take chunks out and reuse them elsewhere. So Lambda is by no means the only way to do this, but what I kind of want to focus on here is writing this pipeline out for us to pass functions to, rather than having these intermediate variables. So as I said, we're going to look at some tweets today. Data processing, and that's what function composition is particularly good for. So we're going to analyze some tweets, which is also another type of application where we want to do a lot of data processing. So before the presentation, I hit the Twitter API, I collected a whole bunch of tweets, and so we're just going to read them from my machine. We're not this isn't live. This is what a tweet looks like. From the Twitter API, you have a whole bunch of other properties, but these are the kind of ones that we want to focus on. And as I mentioned before, our end goal is this graph that we're just going to print to the console. And what I want to do is write a function called getTweetCountGraph that will give us back this graph. Similar to the first example, let's split this into some steps so that we can easily decide the steps we want to do for writing the code for this demo. So the first thing I want to do is I want to clean the data. In this case, that just means removing duplicates. When I was combining all the Twitter data, there's probably some duplicates in there, so we just want to remove those. Then we're going to have a giant list of tweets, and we want to group these all by hashtag. So we want to have a hashtag, and then all the tweets that correspond to that hashtag, and then we can work with that. And then for each hashtag group, we want to count the number of tweets. And then finally, with that, with a groups of hashtags and numbers, we're going to make a graph. Okay. So, get tweet count graph is what we want to write here. And then we're going to just, so I have some code that's already being written here, and I'll explain that in a second. So we're going to make a tweet graph, which is going to call our function that we just wrote, and we're going to print it. So as I had mentioned earlier in the presentation, it's important to control the side effects. There's nothing wrong with having side effects and not pure functions, but we want to control these. So I've actually written a file that says called tweet analyzer side effects, and that has our functions that have side effects. So reading a file has a side effect because it updates the time that you read the file, and as I said, writing to the console has side effects. So these are functions of side effects, so they're controlled in this file. Oh, and you can actually follow along. There was a link to the GitHub repo that has this code in it. And here we go. Can you guys see that? Bit.ly FP with Lambda. If you want to follow along, the code is in there. Okay. So our steps that we're going to follow. First, we want to remove the duplicates. Then we want to group tweets by hashtag. Then we want to count the number of tweets per hashtag, and then we're going to construct a graph. So it's easier to see how this pipe is going to work. Oops, we have to pipe these together with the type signatures. So our removing duplicates, that's going to take in a list of tweets, and it's going to return to us a list of tweets with the duplicates removed. So grouped tweets by hashtag takes in the result of removed duplicates, which is a list of tweets, and it's going to give us back an object that has hashtags as the key and a list of tweets as the value. So now this one has to take in that same thing. It has to take in the result, which is this. And it's going to give us back an object that has hashtag as the key and a number as the value. Oops. This is a list. So finally, we're going to take in that object, and we want to get back a string that we can print. Okay, so if we just sub these out here, we can just get this running. R dot always just, no matter what you give it as an input, it just returns to you whatever's in the brackets. So if we run this, we should just get hi. Okay, so we get back hi. That's what we want. Okay, so the first thing that we wanted to do was remove the duplicates, and we can just compare the ID strings, and if the two ID strings are the same, then we just want to take one of the tweets. So in order to do this, Ramda gives us a function called r.uniqueBy, and you just give it a property that you want to compare. So that's our ID string. So here we can see how easy it is to write these functions that can be composed because of the automatic querying, because of the DataLast API. So I don't even need to mention that one of the parameters, that the parameter to this function is going to be tweets. Because it's automatically queried, then we just get that for free. Then we want to group the tweets by hashtag. So we can use Ramda's group by function, and you just give it a function, and then that function will take an item of the list and basically determine which group to put it into. So we're going to group it by the hashtag from this list. So I'm not going to write this one here because we don't have time. But basically we have this list of hashtags that I just picked. These are the ones that I cared about at the time of making this demo. And we have this function here that gets the hashtag that is in this list. So it takes a tweet, and then it picks one of the hashtags in this list, if there are any, and then it puts it into that group. But if a tweet has, like, say, like The Bachelor and like Node, well, I don't know who would tweet with both those hashtags, but I don't know, that could be fun. It's just gonna pick the first one. So it's not, this isn't perfect, but for the purpose of this demo, it's gonna be good enough. So what I will write is this function called get hashtags from tweet. So here we have in a hashtag, we follow this path, hashtags.entities.hashtags gives us a list, and then the hashtags has a text property, so that's what we're interested in. So in order to get the hashtags from the tweets, first, as I said, we want to follow this path. So r.path, you just specify the path you follow, and then it gets you the value of that path. So it's entities hashtags, and then we're going to get a list of hashtags, and then from there we want to get the lowercase text property of each of these. So to write a lowercase text function, we're first going to get the property at text, and then we're just going to call to lower. So that's going to give us, here we have like a list of hashtags that each have a text. So that will take all the text properties and then just turn them into lowercase. Okay, so let's just see if what we've written so far is working. So I'm just going to, there's like 10,000 tweets in here, so I obviously don't want to print those all out. But what we can do is just look at the keys that we get back from this object. So group tweets by hashtags. This gives us an object that has the hashtags as the keys. So in order to check if this is working, I'll just make sure I get back the right keys. So we're going to call this. We're going to pray. It compiles. And it does. Okay. So the keys of this, the group that our group by function is returning is correct. This is the list of tweets from. Sorry, that's the list of hashtags that I was interested in. Okay, so the final, we need to get the tweet count for the hashtags. So in order to do that, we're going to use Ramda's map function, and just for each hashtag, we're just going to take the length of the list of tweets that corresponds to it. Now, the final step is to construct a graph. So what I wanted to do to construct this graph, I'll show you what our data is going to look like at this point. So at this point we'll have this object. We'll have the hashtags and then a number. So I think that the clearest way to see this is first I want to sort these in order of popularity, in order of number of tweets. And an object's not sortable because there's no order in an object. So what we're going to do is I wrote this sort value was written above, but it's basically going to turn each key value, like each key in each value, into like a key value pair, and then it's going to sort based on the number, and then you have a list of key value pairs. So sort by value is going to give us back it's going to take in this hashtag and the number object, and it's going to give us back a list of ordered pairs that has like the hashtag as the first part of the pair, and then a number is the second one. So this way, sorting actually has meaning. Then after that, for each key value pair, we want to create like a kind of the bar graph that corresponds to that key value pair. So this I also wrote before. So this just takes in this key value pair, and it's going to give us back this like string here that has like the hashtag as the kind of like the x-axis on the graph, and a bar that represents how many tweets were tweeted about that. So we're going to create the hashtag bar, so that takes in the result of sort by value, and it's going to give us back a string, a list of strings. And then finally, we're going to take that list of strings and we're going to join them with spaces, so we get the bar graph. That's going to take in a list of strings, and it's going to give us back a big string. That's our graph. So, does it work? Okay, it's really big. Oops, I didn't think this part through. Okay, here we go. So we do have a bar graph that looks strange, but working on it. Okay, so here we have the result. As you can see, these tweets were kind of gathered at random times, and it's a bit weird because Twitter only gives you back so many tweets at a time, so like it's not actually like really indicative of what's going on Twitter, but it's like kind of fun because functional programming is like more popular than like Donald Trump, which let's just pretend that's the case for today. And Dev Week is more popular than functional programming. More people should be talking about functional programming in the development community. But yeah, so that is kind of how, I hope that you can see from this example how I was able to construct this graph basically starting out with a list of steps in my head, which is, it's kind of I think for me, it's an easier way to code because this is how you think about these things. There's these steps that you want to do, and then you can quite easily transform that into steps in your code, and then you just implement function by function one at a time. And now that we have this, say we wanted to graph something else, like we wanted to graph favorites, or we wanted to graph, like, I don't know, like anything else that's related to the tweet, like grouping, like removing duplicates, we're going to want to do that anyway. So we can keep this step, and then maybe we can group tweets by, like, I don't know, username or something like that. So we would just have to take out this function, replace it by group tweets by username, and then we can keep going. So these are like our simple building blocks that we've combined into this more complex graph, and then it's really easy to take these and use them in other places and kind of manipulate or change our function pipeline when we want to. Okay. So there's 3 things that I want you to take away today. The first thing is you can start writing your code in a functional style today. You don't have to change your code base. It works. You can use it alongside object-oriented programming. In JavaScript, you can use it alongside imperative programming. You don't have to change what's already there, but moving forwards, you can start thinking in this way, and I think that it will, it will help you to write cleaner code. So the main part of functional programming that I think you can use is function composition. You're probably already doing it, but you could do it better. And Ramda can help you do this. So it helps you to write JavaScript in a functional style, and it makes function composition simple. But it's by no means the only way to do this. So you can, like how I said before, you can use Lodash, you can chain with Lodash, you can use the functional programming library that Lodash made. You can even use native JavaScript, and these will all give you the same results. For us, we just thought that Ramda was the easiest way to do this. Okay, so to conclude our story, we have a villain, smiling face with horns. This is unreadable code that's hard to maintain, is complex. But this villain is of course defeated with our woman technologist, and she helps us to write clean code, and your software will benefit from this clean code because it's easier to understand and it's easier to maintain. So the same way that this corgi will defeat the Death Star, our hero defeated our villain, and that's it. That's how the story ends. I think there's 10 minutes left if anyone has questions. Yes?
Every time I see Ramda or composition, I always see r.compose, and you use a lot of pipe.
Yeah.
Is it just left to right versus right to left?
That's exactly it.
The convention why pipe, yours looks way more obvious?
Yeah, so as I said, there's pipe and there's compose, and the only difference is left to right versus right to left. Personally, I actually use compose, but I didn't use compose for this demo because when you're writing down the steps correspond to the pipe steps, so it's better for the demo. People that I work with, it's like an ongoing debate. It's kind of 50-50, and who uses compose and who uses pipe. But I come from a math background, so for me the compose was more obvious because it's the same way you compose functions in math, right? Like you go left to right. Yeah, you do the way that compose does. My left and right is really bad. Okay, but yeah. Now, after I did this demo, I actually think I'll probably start using pipe because I can see that it's easier to read. Because when you read it like a sequence of steps, which is what the people that use pipe in my office would say. They're like, oh, but you can see it, you can read the list, but it actually doesn't matter.
Thanks.
Yes?
Is it any particular reason why you should use Ramda instead of, for example, the Lodash function?
So this is a good question. I would say no, there's no good reason for Ramda. We just used Ramda, and Ramda came first. Leading up to the presentation, I was like reading a lot about them because I really this is an obvious question that's going to come up, and like I actually couldn't find a compelling argument for Ramda over Lodash's, the functional programming part of Lodash. And actually, one of my coworkers was telling me that So originally, the creators of Lodash were working together with the people making Ramda, but then they like got in an argument or something, so they like went off and did their own thing. So there probably at some level is a difference, but it's not big enough for like the internet to be, you know, pulled in one direction or the other. So yeah. Yes.
Do you use lenses a lot?
No. We have a wiki in our repo that talks about lenses. So lenses are like a part of Ramda that one guy in my office got like super excited about it. I was like, this is the best thing ever, we have to use it. And everybody else looked at it and was like, I have no idea what this code is doing. And the thing with Ramda is you can take it too far. Like, the goal of Ramda is to have readable code, and you can do some pretty crazy things with Ramda, but like the end result is you have like, you know, like converge, flip, curry, this, and someone that doesn't know Ramda would go in there and have way more trouble trying to figure out what that's doing than like the big long function that I showed at the beginning. So in my opinion, I think lenses are too far, but if everybody in my office was more like well-versed on functional programming, it might be a good thing to use. Yes?
So going to your types, I guess two questions. One is, what happens if you violate the types? Does Ramda throw an error?
Yes, Ramda will throw an error. Is the error useful? No.
Is that like an exception, like JavaScript style, or is it more functional?
You'll get an exception, and it's usually something like something arity is too small. You read it and it's basically like good luck. But what you can do when you see these errors is like so when you pipe the functions together, in between each step, you can basically write a console log. And so then when you run the function, after each step, it's going to log what the result is, and then you can see where the error is. So that's how you handle it. The errors that Ramda gives you is like completely useless.
And then on that point, you were making tuples yourself. Does Ramda provide like a base
Yeah,
tuple type?
it's called, so you can call like Ramda.toPairs, and that takes an object and then turns it into like a list of key value pairs.